It gives me great pleasure to introduce Dr. Glenn Morris, who is a professor of medicine and a longtime colleague, who is the head of the Emerging Pathogen Institute, an institute at the University of Florida dedicated to studying emerging pathogens, and COVID-19 definitely falls into that category. So Glenn, what I want you to do is to describe what you see as the future using the modeling that you and EPI has actually calculated over the last month.
Okay, thanks. It's a pleasure to be on. And Southwick's indicated, what I'd like to do is start with some slides that show some modeling work that's been done by Dr. Ira Longini, who is a member of our research institute and actually one of the world authorities in terms of modeling of COVID. Works very closely with WHO and actually has been involved with the White House Task Force. So again, what I'm going to show is not my work. This is work by Dr. Longini, but it is, however, posted on the EPI website so that it is generally available. This first slide actually shows for the entire United States the projections of where things will be by May 1st. On the left-hand side is, if you will, the unmitigated projections with no interventions. And again, on the right-hand side are the projections with social distancing in place. And I think the main point to emphasize is that clearly the entire United States is affected. Obviously, the areas of concentration of cases reflect where the major cities are, but this is a national issue. And again, what this does is simply put this into curves with dates. And again, what you see with the current mitigation efforts, we actually have basically passed the time point where we would expect the highest number of new deaths per day, although we are continuing to see a rise in the cumulative infections. If we had had an unmitigated scenario, by this time, the models suggest we would have had over 500,000 deaths, but we would have had a cumulative attack rate of about 55%. With the stay-at-home policy, we're looking, projecting in the range of 50,000 plus deaths at this point in time. But I would point out that the cumulative infection rate, essentially what we've done is drop the infection rate down to about 3.8%, which is good in that we're not seeing the deaths, but is not so good in that we are not building immunity within our population. So there is not a herd effect, a herd immune effect that would protect the population. So even though we have put in this much effort to mitigate the problem, we are still at a point where we have a very high percentage of the population who are susceptible to infection. If we switch down to Florida, again, these same two curves, the curves suggest that around April 14th is going to be the peak time for deaths, or was the peak time for deaths. Again, here, Florida has had fewer cases, and the projection is that we're going to have about 2.8% of the population infected by April 20th. And so this gets back to the idea that if we lift mitigation, we have a huge population of susceptible individuals. And what we're going to get is a fairly substantial epidemic. This simply shows the hospital beds and ICU beds needed. And again, we are very fortunate here in Florida in that the mitigation efforts have been successful, the social distancing, and what you can see is that the projections are that we will be well below the total ICU bed capacity and the hospital bed capacity as well as the ICU bed capacity. So where do we go from here? On this curve, basically we are sort of right here, which is we put these mitigation efforts into effect. And again, this is for Florida. And what you see is the curve is starting to come back down. Okay, but then there's some options as to where we go from here. The purple line is with schools closed, but everything else goes back to normal on May 1st. And what you see, and again, this is a logarithmic scale over here on the graph, and this is the numbers of cases. What you see is that we will have, again, a dramatic increase in cases due to the fact that we've got a very highly susceptible population. The red line is keeping non-essential businesses open, but schools and universities closed, smart working for about 50% of people, restaurants, bars, and mass gatherings shut down. The green line is the same as the red line, except with enhanced testing and contact tracing. And the blue line would be if we keep things like they are right now, with the stay-at-home order prolonged after May 1st. So again, what this does is begin to give you a feel for what the impact is of various interventions. And again, if we put in here the lines up at the top, which basically represent ICU capacity, you can see that the purple line goes well above ICU capacity. So this is the idea that if we indeed have if we stop everything, except potentially keeping schools closed, there is the potential for a major second peak, which is going to substantially exceed our ICU capacity. Again, this is the same slide as before, but just with the ICU capacity lines put on, you can see the red line keeps us with about the same number of cases. The green line lets the case numbers keep dropping, but again includes substantial enhancement in testing and contact tracing. And the blue line is keeping where we are right now, which from an economic standpoint is non-viable. The real question is where on this graph are we going to end up in terms of ongoing case numbers that stay below the ICU capacity lines that are up here at the top of the scale. And in turn, how does that work with the impact of these changes on economic changes? So I'm going to stop at that point in terms of the slides. I think the slides are interesting because what they do is really begin to look at what comes next. And again, open up questions about interventions and the impact that they may have as we move forward.